small amount of code, but the game looks fine. Okay, let's discover Pygame. So at the very beginning, what we have to do is to create the screen. We need to create the display surface. And let's open the Visual Studio Code, or let's open the PyCharm to create our screen, to create the screen where we can see our game in the future. So let's do it. Let's open PyCharm. So let's open the PyCharm. I'll work with the PyCharm for today, but you can work with the Visual Studio Code. It's also option. Let's name it Basics Pygame, maybe 1. And let's create the environment for our lesson for today. So let's see. Let's create the .py file. For example, the new Python file. So, are you ready? Everything is good? Okay. For example, the first one, create screen. Okay. And at the very beginning, we need to initialize the Pygame library here. But at first, we need to import Pygame. How to make comps? Okay, import Pygame. But you can see that we can't do this one because we didn't install the Pygame into our virtual environment. So please be careful that you use the Python 3.11. That is maybe a little important. And also now we need to use this package to our virtual environment. You can see the pip env, that is virtual environment, with the interpreter that Python 3.11. So, and let's download the package here. It is very easy. So now you can see the package installed, and we can work with the Pygame now.
If anyone needs help, just kind of wave and
Yes, that is very important. So if you need help to activate your virtual environment, to change the interpreter, so let's go. And how to initialize Pygame. That is Pygame that init. Okay. Okay. Have it done? Yes. This is very crucial things to initialize. That is means that we download the all modules from the Pygame to work with that. And then let's create our first screen. So what we have to do, we need to decide about our resolution of our screen. That is, can be 600 cross 300 or 600 cross 300. So let's do it. That is window width and the window height. How to initialize the screen or display surface? Display. That is, we need to pygame dot display dot set mode, and we need to add the tuple of our resolution inside this function. So let's go. For example, we need to do this one 300. For example, that is our resolution.
That's all good. We're just starting.
Have you done? Yes? Okay, good. So now let's try to maybe launch this one and let's see what happened. And let's see. Nothing happened. Nothing happened. Yes. Yes, we can see this line that the Pygame started successfully. We can see the hello from Pygame community, and we can see that this code successfully finished on our PyCharm. Yes. Wait a second. But there are nothing on our screen. We haven't seen any screens. So what we have to do? We have to create the way how to work with this code infinitely. How to run this code infinitely. That's so how we can do this? We can use the while loop. While loop, that's the best way how we can do this one. So let's do this one to create while loop. While you can use while true like this. That is the while. Yes, while true, like pass. But maybe after that I need to explain some information for you. So when we work with the Pygame, with the screen, all the actions on our screen, that is events on Pygame, that is events. So, and we need to detect these events before starting our screen. And let's do it on our code firstly. So let's see. That is section caption. Here. Okay, let's see how to do this one. That is for event in pygame.event.get. No, let's print event. And let's see what happens after that. So Run the screen. Yes, that's nice. Now we can see that our screen, that is our surface that we created before. The resolution is 600 cross 300, and that is our first black screen that we created by using the Pygame library. So, have you done it? Yes, everything is good. But let's see, when we are moving on our, can we do this one? No. Maybe. Oh yes. When we are we get some actions on the screen, we can see the actions of the screen. For example, we press the button up, and we can see the button that we press the button, that is events called key down, and we release the button that is key up. And that is a special code of our event. And that is how we can work with the code further in our making games. So for example, when we press the button, we need to do something. When we release the button, we need to do something. So, and all, as I mentioned before, or all our actions on our screen, that is events. So, and now let's make conditions for the quit event, because now if you want to quit from the screen, nothing happens. We can't do this one. And in order to stop our code, we need to stop by using red button. And maybe that is not behavior, so let's make a special event for the quit. For example, when we cross this button, we can see that event called quit. So, and let's do it. But at the very beginning, let's stop. Okay. So, okay. If event dot type, that is Pygame sorry, that is quit. If our event type is quit, what do we have to do? We have to maybe stop our game. That is how we can do it. But maybe it's better to create the flag running true, and we can change the flag into false after that. So running dot false. And now let's test it. Let's go. Now we can see the window, and we can close our window. So that is our first command, the first condition that we include to our first Pygame program that we did it before. And maybe that is also nice. Ooh. It will be nice. Sorry. Yes, it will be nice to add this command, okay, kind of pygame.quit. In the end of our game, it's better to uninitialize or Pygame modules. So that is good behavior. So I really recommend you to use this one. So please pygame.quit. That is very nice. So, and let's see. Okay, that's nice. Our screen are working there. And maybe let's play with the resolution. Let's change it to 600, for example, and let's see what happens. Our resolution changed. Okay. So let's go to our presentation. what I have to say for you is that our core, that is the core for the whole programs that we will create for today. That is the core. So it means that maybe that is the skeleton of all our programs on Pygame. So in all our game we need to init Pygame, we need to create the resolution, we need to create the while loop in order to play infinite our code, and that's all. So please, let's save it and go further. So the next one, let's draw our first figure on our display. What kind of figure we know? For example, line, circle, rectangle. So, and let's create the line on our display that we created before. Oh. Yes, let's create the display. But if you see, when we start with our display is black, let's change the fill of our display surface. So maybe we'll change to black, and let's play to with the color. So for example, how we can change the display fill? So we need to use Discrete. So display.fill, and in this function we need to add the RGB tuple, or we can get the color from our Pygame module. For example, we can change the color from the black to the white. How we can do this one? Let's maybe define the colors. Okay, let's white, that is kind of 255. Okay, and let's add this information to our field, and let's see what happened. Oh. That is. How about this one? Not field. Okay. We see that when we add this information to our display field, nothing happened. Why? Because we need to update our display. How to do this one? Firstly, that is, wait a second. That is in our loop, in our main loop, Pygame dot display display, yes, that update, in order to fill our screen correctly. Let's see what happened. Oh yeah, we did this one. So, have you done it? Yes? Okay, let's go further. And let's draw our first figure on our white screen. So let's see on our presentation. So how to draw the line? We need to use the Pygame that draw that line, and we need to choose the surface. We need to choose the color. There is also RGB tuple. We need to choose the starting point, that is XY coordinate for the start point, and the XY coordinate for the end point, and the thickness. So let's do it. Let's draw the line together. So Pygame dot draw dot line, and where on the display surface. I forget this one. So the color, the starting point, the end point, the color. So let's change the color. So for example, we can use the tuple. For example, 255, 0, 0, for example. Okay, the starting point, for example, 0, 0. The end point, that is, for example, 100, 100, and the thickness, let's go to do it 50. Okay. Let's do this one. Oh, yes, see? We can see our first line. So now I'll ask you to create your own line again. To make your own line, maybe you can start not from 0, you can start from another XY coordinate, and the end also. So I'll give you maybe 60 seconds for this. Show the code. Oh, yes. Okay. The next one. Let's draw the circle. Draw the circle. Is everything okay? Have you drawn this line? Yes, yes. Hands up. Is it okay? Is everything good? Maybe you can better to ask each to upload this Windows, okay? Because I have Mac and I'll do it. Oh, okay, okay. Line is okay? Yes. Line is okay. Ah, okay. Oh. Did you install the Python package with your
Yes,
virtual
but I
environment?
have some syntax because I hate the semicolon. It is nice. Python and
Let's finish your code here, maybe.
Everything is okay?
Yeah, looks like this. Oh, yeah, yeah, that is nice.
Let's just clean this up now.
Did you install the 3.11?
yeah, I have to.
You need to change the Python in here.
Here.
Do you want to use our full extension?
There we go.
Run no. I don't know.
Yeah, I think.
I don't know.
Long development tests.
Yes.
Oh, I see what that. You just schedule up.
And then change. Okay. Okay, let's go further. Let's draw the circle fast.
The other version.
And that is stop our code. Let's draw the circle and then go draw the rectangle. Draw circle. What happened there? Where? Display surface. Display surface. The next one is the color. How we can get the color? I forget, but maybe also we can get the color by using this code, color. What kind of color? For example, yellow. The next one that we need to let's move our circle in the middle of our screen. How we can do this one? As you remember, we create the display surface with the resolution 600. But let's create the variables, stable, constant variables for the window width and the window height. Window width 600 and the window height. Yes. Oh, sorry. Okay, and also you can use these variables instead of the these numbers. And let's draw the circle in the middle of our screen. How we can do this one? We can use our window width, for example, divided by 2, and the window by 2, and the window height divided by 2. And that is also a tuple for our XY coordinate. And also let's add the radius, for example. And the thickness, for example, 10. And let's see what happened with our circle. Yes, here we go. We can see the circle. And you can also make your own circle inside this circle, for example. But we are going further to create the rectangle. Rectangles in Pygame, that is crucial things. So because all our objects on our screen, that is kind of rectangle, that we can download the pictures, we can download the icons, that is small or big rectangles that we move. For example, if some dog it's some mid that is kind of big rectangle, it's some small rectangles. And when the mid are moving from the screen, from the one angle to another angle, that is kind of, when the mid moving from moving from the one side to another side, it means that one rectangle moving from one side to another side. So we all work with the rectangles, and let's draw the rectangle. Pygame dot rectangle display surface, and you can see how we can get the color. That is also nice. So we define the color by RGB, and also we define the yellow color by using the Python module. So now we can change this color here. Okay. So and let's create the new RGB. For example, 255 0 0. Okay. And let's see what we have to do. We need to get what? Okay.
Yeah, I have a question about that. The division you did in the circle.
Okay. Okay.
So you used two slashes, right?
Yes.
So I used one slash and it still works. So what's the difference?
The difference between the one slash give you the float number, the two slash give you the int number, as I remember. So it doesn't matter. So it works on Python. So you can use one slash, two slash. It doesn't matter. Okay. So and we need to give the what have to give for our, that is the big tuple of our, the first one, the x and y coordinate first, for example 0 and 0. The next one is that is the size of our rectangle, for example 200 and 250 like this. And also it can be maybe the fill, and remember, let's see. Okay, let's see. Oh yeah, we can see the rectangle of our that we draw before. So, and I'll recommend you to create one more rectangle, your own rectangle. You can delete this rectangle and create your own rectangle. And I'll give you the small task for you that you have to do now. And also let's play with the fill. For example, we change the 0 into 10, and we can see that our fill changed. So that is our thickness. And let's draw. And if you cancel the thickness at all, it can be 0 by default. Let's see. Okay.
I have a question about drawing rectangles, or actually like anything. So how do you know which parameters this function accepts?
This function accepts?
Draw rect, right?
You just can. Yes, you can use the hint. Look. That's the parameters.
Oh,
so
I
the
see.
color, rect, so width, radius, so the surface that we can.
But for example, there is rect and rect type, right?
Yes.
So what is it? And how do I discover it?
I know that may be kind of object of this function. So what we have to know about this, we can see on this line that we need to add the tuple of our rectangles.
Yeah,
by using int, and that is acceptable for drawing the rect. So maybe it's kind of piece of our object. So I'm not sure. I'm not. I don't know the deep understand for that mean.
I'm using Visual Studio Code and it just shows rect. So maybe I should change my ID.
I know maybe you can download the hints on the Visual Studio Code, so you can download the extension. I don't remember how it works on Visual Studio Code, but you can do this one. Okay, so and let's see. So the rectangle, we draw the rectangle, and I'll give you the small task for you. So let's go. Peach, are you ready to create the task for you?
For me?
Yes, and you, for all.
Sure. I'm
Yes.
helping you.
Okay.
Sure.
So let's go. So now you need to move our rectangle from the left, top left corner into the middle of the screen. So you need to define the exact XY coordinate to move our rectangle in the middle of our screen. So let's see. Maybe I'll give you the 2 minutes or 3. You can try. You can challenge yourself, and after that I'll show you the answer of that.
I have a question.
Yes.
My computer is getting hot. And I can see that Python is consuming like 100% of CPU. Is there a way to like quickly solve that?
How to quickly solve that? Not so hot. I know. So how?
Do you have it checking for the events every loop iteration?
Yeah. This is while true, right? So it's like looking
Yeah.
Right, but it shouldn't do much though.
Yes.
That should be optimized away.
You can maybe stop the running code.
Yeah, I
Stop and just try to
Okay.
type, and after that you relaunch the code. So
Okay.
maybe the best way.
Yeah.
Exactly in the center of the screen. Oh my God, what's wrong? So if you have done, so just raise up your hand. It would be nice. Exporting the field. And instead of the color units. From 0 to 5. tuple, tuple, tuple. So have you done it? Have you did this small task? Okay, let's see.
Oh, that's nice. Oh. Yes. Have you done it? Oh, it's nice.
It's nice. That's nice. So I see that you did it. So let's see. At the very beginning, I want to show you some cool things. So I import randin from random to change the display surface fill randomly. So we define the RGB randomly. So when we start our screen, you can see that the color, everything changed every time. But what happened if we move this line to our main loop? Maybe here. And let's see what happened. Oh, our display changed because our loop worked very, very fast. So, and the RGB changed every time, so fast. And how we can make our loop slowly? How we can do this? We can define the clock. How to define the clock? Clock Pygame dot clock and remember, let's see. Yes. Time. That clock. Yes, now it's right. And we can manage how fast our loop work on our program, because the clock can tick, and we can. The clock is kind of the clock, but we can define the how many frames per second we will show on the each second. That is, for example, clock dot tick dot, for example, 10 times. We can do this one, and let's see. Yes, now you can see that we make our loop more slowly. Yes, by looking clock. Or you can change it to, for example, to 1, and let's see. There is 1 color per 1 second, 1 cycle per 1 second. Huh? It's not now. So, and now let's move our rectangle from the answer of how to move our rectangle from the top left corner to the middle. So let's see. That is. So as you remember, we defined the resolution 600/600, and let's define the right coordinates of our rectangle x and y coordinates. Let's see how it works. For example, let's make a rect x and rect. Why? How to make it for in the middle of the screen? Let's divide it by 2 at the very beginning. With by 2 window divide. Divided by 2, and let's see what happened after that. So let's add this information instead of 0. And oh no. Oh, that is very nice. It's very nice. Okay, let's see. Now you can see that we tried to move our rectangles from the left corner, top left corner to the middle, but nothing happens. And that is very important thing that I want to show you. When we move our rectangles on our screen, we keep our rectangles by this angle, and you can see that this top left corner is exactly on the middle of the screen, exactly. So in order to move this rectangle in the middle, we need to minus the half of our window rectangle width and the half of rectangle height. So let's do this one. Let's close this one, and here we go. The 200 minus 200 divided by 2, that is 100, and that is 250, that is 225. And now you can see that our rectangle exactly on the middle of the screen. So that is very important to know how to move our objects on our screen, because that is not intuitively understand how to move this object, because we don't know where the program, the Pygame, keep our rectangle. And I should notice that the 0, 0 xy coordinate started from the top left corner. That is 0, that is 600, that is 0, that is 600. So that is x coordinate, that is y coordinate. So let's go further. The next one. And now let's create the code that help us to move our rectangle, to move our object on our screen. So we work with the red rectangle. So and let's define these conditions in our main loop. So let's go. By pressing the key, by pressing the key button on our laptop. So let's see. So if you remember that all actions on our screen, that is events. So and we define the what we have to do if we press the button quit. So if the event type is quit, we need to run in false, so that we need to stop our loop cycle and close the game. The next one, define if we press the button up, if we press the button down, if we press the button left, and if we press the button right. But at the very beginning, it's better to define the step. How many pixels we move, press one button. For example, it can be, I don't know,
Okay.
Not okay, sorry. Okay. Step. So let's go. If event type there is Pygame dot key up. So if we press the key up, what we have to do? We need to move our rectangle up or down. So if you remember, we defined the rectangle y coordinate. So let's maybe key up that is minus, and is minus 2 step. So why minus? Because as I mentioned before, that we start from the left, top left corner. So and we need to, if we minus, we need to move from the center to the up. So let's go. The next one is the same code maybe for key down. But now we need to plus. The next one, if event type Pygame dot key left. Yes. It calls rect x minus pi, not 10, it can be step. And pretty the same with the okay. Okay. So let's see. So if the event type is key up, we'll move to the up. If event type is key down, we'll move down by step. If the key left, we need to move to the left by step, and the same with the right. So let's test it maybe. If you're finished, let's go to test it. Now, as I see, I try to press the button, but nothing happened. So we need to fix something. So what's wrong? Maybe that is why we didn't draw our rect on the main loop. So, and let's try to draw it here in order to change. Nothing happened. Rectangle X, rectangle Y. So let's try. We press this one. And maybe let's see. Hmm. That is in our for loop. Huh? Key right, key up, event works. Mm. Mm-hmm. Ah, yes. Yes. That is very important thing that I forgot to add to our code. We need to check if our event is Pygame key down. We need to define that we press any key. So let's do it. If event that type Pygame that is key down, if you press the key, and if the event key yes.
Okay.
Oh, now we can see that our rectangles is moving, but I forgot that we need to check our clock into, for example, 50, and let's see how it works. Oh yeah. Now we can move our rectangle. So one more time. So let's see that at the very beginning we need to define that we press the key. If we press the key, that the event is pressing. Let's see. For example, one. Let's see that it means that we press the key, we defined it, and then we check the key and give the conditions of that key, for that key. And also you can change the step, for example, to 25, and check the clock. So check the tick. So, and let's see, it can move firstly. But let's see that our rectangle are moving out of the screen. That is what we have to do to restrict our screen. But at the very beginning, let's play with the continuous movement. When we press the key, when we held the key, and our rectangle are moving continuously. For example, we press the key up, our rectangle are moving continuous uply. So how we can do this one? If we press the key, that is event on the Pygame. If we release the key, that is also event on the Pygame. But if we held the key, that is not event in the Python. So in order to realize the continuous movement, we need to make some interesting things. So let's do this one. I'll give you maybe two types of continuous movement. We need to do it in 3 steps. The first step is define the flux. When the rectangle is moving up, they're moving down, left and right, and define the false for that flux. Then we define the logic for this flux on our for loop. and we need to move our rectangle, but not in for loop. Why not in for loop? As I mentioned before, because the continuous movement, there is not an event. So we don't need to check the event in for loop for this movement. So just define the logic for our flags. So let's move this one. Oh. Sorry. But at the very beginning, I want to ask: have you done this movement? Is it okay? Yes. Have you done it? Yes. And you? Is it okay?
I think I mistakenly erased white.
White?
Yes, white is.
Define the white color. So define the white color.
I mistakenly used the definition of white.
So what should I write? Listen to everyone when they start making games. The display surface fill is doing that for every iteration of the game. And what that does is it basically wipes out that. Because what you're doing is you're drawing a rectangle, you're drawing a rectangle again, you're drawing a rectangle again, because you're never cleaning the whole pixels. You can just move your display surface fill to inside the loop before all your other stuff. It should work.
You haven't specified what is Windows.
Yeah.
Well, that's
You just need copy paste, right?
yeah, that's fine.
Yes.
Because it's not doing it.
Right equals 600. Okay, what is Windows and then it's the result.
That one will use PyCharm.
Yeah.
But
Here you just put 600.
Okay, okay. Let me help you.
Yeah.
So you're writing Windows is 600
Ah.
and Windows is also 600. And move it
You have to work those out.
Ah.
Your speed is very
You
high.
can change it also here.
But it worked. Very good. Anyone else need help?
Windows, sorry.
Oh, my battery. Shit.
Okay, I guess I'm moving over here. Oh wait, so the you're right.
Here you can see the downloading, the green line. Here, this one. Let's see. Oh, too much PyCharm here, so let's check. So let's move because we don't have time. So let's define the flag at the very beginning. Define the flags for continuous movements. For continuous. Okay. The first one is rect is moving. Moving up.
Yeah.
That is false. Then the same one with the down.
This whole block here. Yeah.
Left, and right. So, and let's define the condition for these flags. That is when we need to define the pressing the key. If we'll press any key, not now any key. So we need to change our flag from false to true. So let's do it. Key up. So rect is moving up into true. So, and we need to do pretty the same with the another. If the key down, that is also true. Down. If that is key left, that is also true. And if it's right, it's also true. But how to understand when someone releases the button? We also need to control this one and change our flag when someone releases the button. So when someone, we need to add the special condition for event type Pygame key up. Key up, that is the events when someone releases some button. So, and let's add this condition for these events. So let's copy this. But we need to change key up to key down, or key down to key up, and add condition for this if event dot key Pygame dot key up. If we press the button key up, we need to change our flag from the true to false. So rectangle is moving up, false, to make it false. And the same one with the another button. So let's do this one. The same condition. Key down, down. That is left, left. That is right, and that is right. And as I mentioned before, so the holding the button that is not event. So now it's not needed to this. We need to move this condition from our for loop out of our for loop into while loop. So if wait a second. If rect is moving up, we need to change our we need to change our rectangle y coordinate minus our step that we defined before, and pretty the same with the if the rectangle is moving down, let's change it to rect y into plus step. The next one is if the rectangle is moving left, rect x minus 2 step, and if the rectangle is moving right, so rect x plus 2 step. What I have to do? What does that mean? What this condition mean? If that means true. So we don't need to write equal 1 or equal true. That is true by default. So if true, please move left, move right. If true, move left. If true, move down. If true, move up. So we check the flag that is true or false by our logic that we defined here, and then move our rectangles out of for loop in our while loop. So, and now let's try to do this one. Nothing happened. Let's check what's we need to here, move it here. Yes. Oh yeah. It's too fast. It's moving. Key up. And let's stick it into 1. So let's see. So slow. Step down, step minus, step plus. Even key. Hit the even key, Pygame right, left, Pygame down. Yes, we forgot to cancel this.
Oh, you're double moving.
Yeah.
So one thing I usually like to do is instead use velocity.
Yes, instead of step, we can use the velocity.
Right, and then separate rendering from updating.
I think I found an easier way. So there is a function, it's called Pygame key get pressed.
Yes, that is the second way how to move it continuously. That is on my presentation that we need to learn it in very
Number 2 eager.
no, number 2. I don't see that. Key up, key down, key left, key right, true. Do this event key. Let's see. False. Let's check our code with this presentation and let's see it's work on your laptop or not. У меня то же самое, ошибка PyCharm, помнишь? Я ищу. Event type, event key. Oh yeah. Oh yeah. Now it's work. So is it okay? So if you have done, if you have done, here, here. Have you did it? Yes, good.
Because we need to fill the this place. Like we need to update our field.
Good. Yeah. Okay. So now we realize the continuous movement on our screen of our rectangle, and I want to notice that the holding of the key, that is not event. So please remember this. And the second way how we can make the continuous movement on our screen. So we can create the variable and put to this variable the key get pressed, so that the key get pressed. So we can do this one, and then just check if the keys that we need in our variable here. We check if the key is pressed is here. If it's here, so we need to move. So pretty the same condition like with the discrete movements. So let's do it. Let's go. And also maybe yes, as that Anna told that it's better to skip because we don't have enough time. So, but please remember that you also can get the continuous movement this way. That is easy way, and it looks good and works also good. Not so complicated and so readable. But currently, so we check if the key is pressed or not. So maybe I'll show something.
A question. With this implementation here,
Yes.
if you're pressing left,
Yes.
and then you press up, will it go diagonal, or will the left block the up?
Not block.
Okay, cool.
So we can press 2 buttons and it works.
So there's more on the implementation.
Okay, but let's see the, maybe that is also nice to check this implementation. Maybe let's see the keys that get pressed. And that is very nice to print keys. Hmm?
So I did a different implementation, but sometimes it's stuck. But I did it differently than this, so don't worry about it.
Okay, okay. So, and let's see what happened. We do this one. We do this very nice. So you can see the maybe tuple of false. That is our zeros. Now we print our keys here. So, and you can see the false. And if we press some key, maybe you can see maybe no, like this. Printed too much. Here. Delete the events. And let's do. Okay. You can see the false, but sometimes you can see true. For example, if we, for example, true, it means that sometimes we press the button and the tuple changed the zeros into 1, so it means that it changed from false to true. So, and according to this realization, so that we just check if the key is in, if true, as I mentioned before, if true, so just move our rectangle into one side. So now this one small task for you that is so easy. So please restrict the movement out of the screen. So as we see that when we move continuously our rectangles are going out of the screen. That is not good. So let's restrict our screen. So maybe I'll give you 2, 3, 5 minutes, and after that I'll give you the answer. Now maybe.
Yeah, keys pressed is the way to go.
Correct. X. If you have finished, just ask. You let me see. Just tell me. If you have finished, just raise your hand. So, oh wow, so fast. Right. Okay.
Oh, that's nice. That's nice. Two lines. Okay. Oh, wow. Okay.
So let's go further. I'll show you the answer. The answer is that. So we need to add the restriction to our code. So of our XY coordinates, so that the maybe the top left coordinate x should be more or equal step. The top right x coordinate should be less than window width, and kind of plus rectangle width and the plus step. And pretty the same with the coordinate y and coordinate y for the moving up and coordinate y for the moving down. So let's rewrite this one on our code. Let's add this special condition to our end. Why this condition is not good in our tasks that I mentioned before? Why we should add step here, not 0? Who knows? So just give me the answer. Should be less or equal window width minus rectangle width, rectangle height. Okay. Rectangle height, and that is okay. And rectangle x less than window width, here window height, this minus minus plus rectangle. Yes. As you see, I didn't maybe add the step more or equal, okay, 0, and here more or equal 0. So I didn't add the step, and our step is 25. Let's add to 50 maybe, and let's check this condition. As you see that when we forget about step, the piece of our rectangle are going out of the screen. That is not correct. If you want to see this one, let's print, for example, rectangle Y, how it's work. So let's see. Oh no. Let's see. That is means so that this condition that we define here, when that is also true when the our coordinate is more or equal 0, that is also minus our step. That's why the piece of our rectangles are moving off the screen. So that's why we should restrict this one in two ways, or just using the more than 0 strictly, or just using like step here. But I recommend to use step because we also have to add this one on our next condition here. More than 2. Okay, and now as we see that our condition worked correctly, and we maybe our step is so big in this case. 10. Oh yes. Now it looks much better. So, okay, go further. So how many? We have only 10 minutes. So that is the next one, how to blit the images on our screen. So now we work with the rectangles. We know how to move our rectangles. We know how to draw the line, draw the circles. And now let's change our rectangles into image. But at the very beginning, I want to show the very good website. It calls iconarchive.com. So we just open this website and let's see how it works. Let's add the icon archive, and you can, for example, if we work with the dragon, so, and you can just find the icon that you like. For example, I choose this icon, you can choose that icon that you want, and also you can work with the files that I send you on Discord. Just download it and put this file into our directory on PyCharm or Visual Studio Code. So just notice that it's a very good website. You can save it, and let's go further. But now let's add the image to our screen. I also have to add these websites, these assets to our project. Huh? Okay, and let's. Okay. Okay, now we're all set. So you can see the images here. So, and let's try to add these images to our screen. So let's, at the very beginning, we need to load these images to our, load the image from our directory. So how we can do this one? So you can define the variable and use the pygame.image.load and give the way to syntaxes where the Python can find your image. And then you can, I don't know, can get the rectangle tuple from that image by using getRect function. And then we need to locate our image on our screen. That is XY coordinate. So let's try this one. Sorry. Okay. For example, dragon image, there is pygame dot image dot load, and how it goes for the dragon, right? For example, dragon right dot png. The next one, dragon image dot rect. Dragon image dot get rect, and let's define the XY coordinate dragon. Let's see. So that is interesting thing. For example, 0, 0. I use the top left. What is that? And that means how we can we define the rectangle of our image here, and now we define where we can keep our rectangle when we move this picture on our screen. So the top left, it means that we keep our rectangle here. Also, we can use the top right. We can keep our rectangle here, or we can use center, that we keep our rectangle here. So, and you choose whatever you want. For instance, center, dragon image rectangle, or top right is also okay, but why red? Yeah. So you're right. Oh, now it's okay. Top right or center. You can see center, top left, top right, bottom right, left, center X, center Y. You can define the coordinate whatever you want, but we use top left. Okay, so, and let's try to see what happened on our, doesn't happen, there are no images here. So why no image? Because we need to blit our image in our while loop. And let's do this one. How to do this one? I can show you on our presentation. Just put the display surface dot blit and put the dragon image and dragon image rect into this function called blit.
Is Blitting like English word?
Huh?
Is Blitting an English
English word.
word? Or what does it mean?
I've only ever heard of it used in rendering. I don't remember its exact meaning.
Is that the problem? It's because the Google Translate didn't translate this word, so it's yes, yes, like I don't know, maybe отобразить, like show this image on the screen, like that.
It's to copy bits from one part of a computer's graphical memory to another part.
Oh wow.
So basically, like in old school embedded game development, what you would do is, rather than write everything to the graphic memory directly, if the CPU is running slow, you get tearing, and the graphics would be all jacked up. So what you would do is you would write to just some random access memory, some RAM, and then it'd use direct memory copy. No,
Like
direct
from RAM memory to the graphics card.
Yeah, and that's instant, and that would be the blitting.
Got it.
So you write your updates to RAM, and then it flits over to the graphic memory, and you don't get tearing, and it's really fast.
Nice.
That,
When you got to school, man.
dragon image and dragon image rect, and let's see. Oh yes, see, we can see our image on our display, but let's see that now our dragon is not moving. We need to change the we need to change the moving condition in our code. But now we know how to add our image on our screen. So let's see how to make our in order to understand how to make our dragon move, let's print what is that. Let's print what is that dragon. I know. Let me see. Dragon image rect. Dragon image rect means. So, and after that, maybe you should understand how to change your condition on our code to make your dragon move here. Let's see.
I didn't catch that. Could you try again?
What is that? Let's see. So we print this dragon image rect. What is that? That is that.
I found this on the web.
That is the size of our rect of our picture, 64 and 64, and that is x, y coordinate of our image. So in order to change our condition, we need to get the x and y coordinate from this tuple and add it to our condition. What's wrong with the Siri? How we can do this one? Instead of this, instead of here, we need to change the rectangle dragon rect dot y, and now we can get from this tuple the y coordinate, and let's add it here.
Can I give you an example?
Yes.
Can you right click rect Y?
Here.
No, rect Y. Down in the next line. When you have it not corrected yet, so if you right click that. go
To change every, yes.
Yeah, yeah, yeah.
Refactor,
And
rename.
That will read, and then just paste.
Yes.
Okay, never mind.
Okay.
Yeah.
But okay. Okay. Okay, that is X. X. Okay, okay, okay. And let's try to check our dragon move or not. Oh yeah, now we can move our dragon. So as we see that we get the xy coordinates from our tuple from the I don't know that we use the function to get the rectangle numbers of our image and add it to our variable dragon image rect, and and we work with this object to work with xy coordinates, so to change the logic of that of our condition. So maybe timeout. Yes, time is up. Yes, the next step that I want to show that is define the phones, pretty the same. So we can check the available phones of our Pygame module, and also we can define the custom fonts from the websites phonspace.com, and it's kind of the same to add the image, to add the fonts, to add the image, to add the text on our screen. Also, we don't forget that we need to bleed our text on our screen. Maybe the same is with the sound. For example, maybe I'll give you 1 or 2 minutes to play the sound. That is nice. So let's see. Let's add the sound to our game. How to add the sound? Okay. Add the new, maybe background music. So at the very beginning we need to find that mixer that music that load and music wow, and let's we define the music, and now we need to play this music. How to play this music on our background? Just use the simple. Oh, sorry. That is Pygame dot mixer dot music dot play, and remember what we have to add here. Loop starts fade milliseconds, so -1 point no.
So how can you get this music? I mean, I went to that Flash Labs, but I don't see any music.
Oh, there is. I will send all music set on this Discord. You can download, but if the Flash Labs, you can open the. and you can make, for example,
Oh,
sound
okay. Okay, cool.
and download it for free.
But that's not music. I mean, this is supposed
That
to be
is
like-
sound effect. Sound
yeah.
effect.
So this is like background music, right?
Yes, 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 yes.
Okay.
Yes, that is background music, and it works here. There are no sounds here. That is on my laptop. So now we add the music to play. So and also you can add the sound effect if, for example, the dragon touched the something and it's boom. So I can show shortly how it works. That is Lashy Labs. Just use this one if you need sound effects. For example, no, boom, to explode, or create your own sound effect manually and save this wave and add this wave to your game. But now maybe we need to finish our lecture, unfortunately, and the next section is the collision detection, when the one object detects another object and touch and something happens. That is very nice. Why I want to show this one, because file PyCharm. Open feed the dragon. Maybe we will create this simple game here. Let's see how it works. But maybe not for today, for part 2, for the next week. Maybe you can come and we will create this game. But overall, to conclude our lecture for today, now you can understand how to make a screen, how to make a rectangle, how to create a rectangle, line, circles, and other figures on the screen, and also you know how to move these figures on the screen, and also now you know how to add the image on our screen and how to add the sounds to our screen. If you have free time, you can play with this stuff at home and maybe create something to change the fill the screen, to add the one more object, for example. I know to add the coin. So you see the coin, so let's add the coin to our code here. I use this coin, so you can use your coin. So and add this coin to your game, and maybe, I don't know, try to create the moving of that coin randomly. So okay, thank you so much. Maybe next lecture I'll show you how to detect the collision between two objects. That is task 3, but not for today. To make rectangles. One more crucial things, but not for today maybe. About FPS. So as I mentioned before, we create the clock, and I want to talk a little about FPS. We all know what is the FPS, yes? We all play the games, and we all like when our FPS is higher. It means that our game are working smoothly, fastly. And we also can add this FPS to our game if you want. But let's go further. Why we need to work with the FPS? Because some laptop work slowly, some laptop work fastly, some machines more power, some machines not power. The FPS, that is the limitation of our loop, of our frames per second, in order to make our game uniform on different machines, to work maybe the same, with the same speed, and not to change the velocity, not to change the step manually, because it's not maybe good behavior. So congratulations. Now you know some maybe stuff how to work with the Pygame, and thank you so much. I'll add all the lecture and all the today's information to my GitHub. You can just open my GitHub and download this one. Not only how to add the image and the sounds, I'll add the how to collide, I'll add how to blit the text, how to add the text to our screen. And also, let's keep in touch. Just add me on LinkedIn. It would be nice. So, and text me if you want. If you have any questions, and if you play with the Pygame at home, you also can ask me some questions, and I'll try to do my best to help with the Pygame. Okay, thank you so much. Can I ask you, you like it? For sure. Sorry, sometimes the problem with machines, there's Windows, virtual environments, different Pythons. So, but that is every time when it comes there, every time we have this problem. So.